This is JuiceFS. It's a high-performance, open-source distributed file system designed to provide the infinite scalability of cloud object storage with the full functionality and speed of a local file system. In this video, we'll take a look at JuiceFS, see how it works, and I'll show you how you can set up your own local high-performance network-attached storage solution with JuiceFS. It's gonna be a lot of fun, so let's dive into it. So standard object storages like S3, Google Cloud Storage, or Backblaze B2 are incredibly cost-effective, but interacting with it typically requires specialized APIs or specialized tools that break traditional application workflows. JuiceFS acts as a transparent abstraction layer. It separates your data from your metadata, pushing raw data chunks directly to your cloud provider while managing the file system layout, permissions, and directory structures inside a fast database like Redis, Postgres, or TIKV. What makes JuiceFS completely different from traditional cloud gateways or standard network file shares is this strict architectural separation and its aggressive multi-tiered caching engine. Instead of forcing your applications to wait on high latency cloud network requests every time a file is accessed, JuiceFS breaks files into small optimized blocks and utilizes a local NVMe or SSD partition as a hot scratch space. The first time an application reads or writes data, it communicates over the network, but the second time that data is requested, it serves instantly from local storage at hardware line speeds. This allows legacy applications, databases, machine learning training pipelines, and container environments to run directly on top of object storage without rewriting a single line of code. So all that sounds great, but let's test it out for ourselves and see how it works. So for this demo, I'm going to set up a local network attached storage, or NAS, which will host all my data in my own remote S3 bucket, and we'll use Redis as our metadata engine. The very first thing you want to do is spin up a Redis instance with Docker, and you can easily do that with this command. And then we need to initialize the file system by running the JuiceFS Format command. This step tells JuiceFS exactly how to map our database to our storage bucket. We pass it our Redis connection string, our AWS S3 bucket name, and our cloud access credentials. But before doing all that, make sure you have created an S3 bucket and an access key and a secret key before running this command. I had already created mine beforehand, so now when I run this, JuiceFS doesn't actually alter anything inside our S3 bucket yet. It simply configures the storage schema inside Redis and assigns a unique UUID to our new virtual file system. And once the format step is complete, we mount the device to our local machine using the JuiceFS mount command. We point JuiceFS to our Redis instance and provide a local directory path, in my case a folder inside my home directory. And before you run this, there's an important caveat if you're on a Mac. Because Mac OS doesn't support custom file systems outside of the box, you need to install a kernel extension utility called MacFUSE first. This provides the underlying software hooks JuiceFS needs to communicate with the Mac operating system. And then I'm also providing this flag with the free space ratio, because by default it sets it to 20% of your drive, which is quite high. And basically it tells JuiceFS that if the local drive hosting your cache drops below a certain percentage of its total capacity, it needs to stop writing new cache files and start aggressively purging the oldest, least accessed blocks. This keeps your local operating system from completely running out of disk space. Alright, so now let's run this command. And the second it executes, the operating system registers a standard POSIX-compliant file system mount. And to the computer, it looks like we just plugged in a massive external hard drive with 1 terabyte of available space. And now I can easily drag files into this directory like it's an external drive. And if we now go to the S3 bucket dashboard, we see that JuiceFS has stored our files and split them into data chunks. And all this happens behind the scenes, and we don't have to do any of the heavy lifting. And to show you how the caching works, we're going to benchmark the file system using a classic terminal command dd. So if you haven't used dd before, it's a built-in utility used for raw data copying And in this specific command, if stands for input file, which is pointing to one of our large video files that I added to our JuiceFS drive, and the off stands for output file. And we're routing this data straight to dev/null, which is exactly a black hole in our operating system that disregards data instantly. Because we're not actually copying the data, we're just doing a benchmark in this example. And we also set the block size to 4 megabytes to match how JuiceFS slices data chunks. And finally, we prefix the whole line with the time utility so we can see exactly how long the file transfer takes. And the first time we hit enter, this is what is called a cold read. Because the file was just uploaded, our local machine doesn't have a copy of it yet. So JuiceFS has to reach out over the internet to our S3 bucket, fetch all of those 4 megabyte data chunks one by one, and stream them down. And on my connection, the first run takes, as you can see, considerably long. But watch what happens when we run the exact same command the second time. So boom, there you have it. The terminal prompt returns almost instantly. The second run took less than a single second because now it's in our cache and we're reading it organically. So this is how the multi-tiered caching engine works in action. While JuiceFS was busy downloading those chunks during our first run, it was silently copying them into our local NVMe scratch disk. But on the second pass, the system bypassed internet entirely, pulling the data directly from local hardware line speeds. So you get the infinite cheap storage capacity of the cloud combined with the zero latency speed of a local drive. So in this demo, I used video files to showcase the functionality, but this applies to almost any real-world infrastructure scenario. If you're a DevOps engineer managing container environments, you can just use JuiceFS to provide shared persistent storage across a Kubernetes cluster. And instead of paying for expensive cloud block storage for every single node, all your pods can mount the exact same JuiceFS volume simultaneously, sharing configuration files, application assets, or user uploads globally while keeping costs incredibly low. And it's also a massive win for machine learning and data science pipelines, because if you have a massive data set, say hundreds of gigabytes of training images or text data sitting in an S3 bucket, training an ML model usually requires downloading that entire dataset locally first, which wastes time and storage space. But with JuiceFS, your training script can start running instantly. The pipeline reads the data sequentially through the mount, and JuiceFS handles the high throughput streaming and local caching in the background, keeping your GPUs fully saturated without local storage bottlenecks. And there's one more cool thing I want to show you. You can also easily hook up metrics to your file system with BetterStack. Every time you mount a JuiceFS volume, it silently spins up a local Prometheus compatible metrics server in the background. If you open your browser and go to this URL, you can see all the metrics here in plain text, which are tracking every cache hit, read duration, and S3 request errors in real time. And to pipe this telemetry data directly into our dashboard, we can use BetterStack's native Prometheus scraping feature. First, we need to go to sources and connect our JuiceFS as a source. And let's choose Prometheus scrape from the metrics tab and click connect source. Now we need to ingest our logs, but before we do that, we need to open a secure public tunnel to our local metrics port using a tool like Ngrok, and then paste our Ngrok URL. But to make it work with Ngrok, we also need to go to the advanced options and add a custom HTTP header named Ngrok skip browser warning and set it to true. And this tells Ngrok to bypass the warning page entirely, allowing BetterStack to scrape raw metrics securely every few seconds. And now our metrics should start ingesting automatically. And let me show you the coolest part. If we now go to BetterStack's AI SRE, we can just prompt the AI SRE to create us a dashboard that monitors cache performance or latency and the throughput of our system. And in a few seconds, the AI SRE will craft us a custom beautiful dashboard with all the metrics coming in from JuiceFS. And we can also see that it is updating in real time. So how cool is that? So I hope this little demo shows you just how powerful JuiceFS can be when you combine it with modern infrastructure monitoring. We managed to take a cheap standard cloud storage bucket, turn it into an infinitely scalable local drive operating at hardware line speeds, and hook it up to a fully automated observability dashboard in just a few minutes. So there you have it, folks. That is JuiceFS in a nutshell. What do you think of JuiceFS? Have you tried it? Will you use it? Let us know in the comments section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video, and also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.